Kia ora koutou, everyone. Just got a friend coming on stage as well. So, wouldn't it be amazing if on the farm we could afford to handpick each individual weed and we didn't have to worry about herbicides in our foods? Or if we could afford to manually remove every single bug on a plant and we didn't have to worry about pesticide residues ending up in what we were eating. Or if instead of chemically thinning our apple trees, we could have people go around and just pull apples off the tree. It all sounds incredible, right? But there's no way you could run a profitable business like that. And there's also the fact that a lot of those jobs wouldn't be much fun to do. So what are we forced to do? We're forced to use harmful chemicals that are known carcinogens and endocrine inhibitors. These are chemicals that damage our waterways, pollute our soils, and actually cost growers a lot of money to purchase and apply. So, did you know that a study from BMC Public Health over in the States has shown that every single year there are 11,000 deaths attributed to agricultural chemical poisoning? Or that according to Dr. Shauna Swan's research, they've been able to show that in areas with increased glyphosate use, there's been a statistically significant alteration to the female reproductive development process. Or that here in New Zealand, the Ministry for the Environment has been able to show that there are traces of pesticides in over 70% of our fresh groundwater sources. So we don't really use these chemicals in agriculture because we love them, but we use them because we don't really have a choice. And so, you know, with my farmer hat on, I've spent hundreds of hours spraying, and as a farmer, they're a bloody good tool to have in the toolbox, but I think we can make a better tool. So, what does that tool look like, and how do we get there? So, meet Matilda. So, young Matilda here, she is in her infancy right now, but when she grows up, she's going to have some pretty cool tricks. So, over the last couple of years, we've been engaging with the University of Canterbury and their research group UC Vision, and they've been working on some pretty groundbreaking technology. So, Matilda is by no means the first agricultural robot in the world. There was some mention of Robotics Plus earlier, who are doing amazing things, but Matilda is quite unique. So, Matilda is the first robot in the world that can see and understand the world in 3D, just as us humans do. So she's the first robot that can generate photorealistic 3D renderings just from video scans. So this here is what Matilda sees, and the level of detail is incredible. You can see in and around leaves, and you can see nodes on canes. We've even had it where you can see individual lines of silk on spider webs. It's that detailed. With these models, we can move in and around the plant, and we can see things that, if you were just relying on videos, would be tucked away. So, to be clear about sort of what's happening here with this research and the idea that I'm trying to convey to you. So, Matilda's pretty cool with her camera bar here, and it's cool to go around an orchard or a vineyard and get these scans. They're amazing, they're somewhat mesmerising, but it's not about the data that she gathers. The amazing thing is what we can do with this data. It's what becomes possible with clean, clear data that actually represents the real world. And it's the types of automation that unlocks. So this is really the main thing that makes the shift from using video technology for robotics to using 3D reconstruction technology for robotics a massively transformational shift for, in particular, the horticulture sector. So I'm going to tell you why. So it turns out that trying to build robots that do things that seem relatively simple to humans, like pruning a tree or thinning a tree or harvesting a tree, they're actually bloody hard problems to solve with robotics. So Over the years, there have been many attempts to build robots for doing these tasks because there's a lot of work to do there, basically. But these systems have been based off stereo cameras and LiDAR, and that method of doing things, it's a really good method for seeing things around you, but when it comes to actually interacting with things around you, you start to run into some problems. So these previous systems, they don't really understand that what they see through those, through LiDAR and stereo and video and whatnot, they don't really know that that is a representation of a 3D world. With those existing systems, it's possible to, get a robotic arm to move and do things, but, to have something that's taken by the market, you really need something that can work at the pace of humans or even faster than that pace and not damage the trees and not damage the fruit, right? So because of this, we've basically seen most of the robots that have been built for this space, they end up gravitating towards vegetable crops, because vegetable crops essentially represent a 2D plane, and they can apply that sort of technology to that problem. So I'm going to go into a little detail onto why exactly this is a challenging problem and try and illustrate it a little bit. So I want all of you right now to imagine that you are in an orchard and you're going to go prune a tree, right? So you generally walk up to a tree and with your eyes you look over the tree and you do some sort of an analysis as to how hard you want to prune that tree. Then you sort of look to see where you want to start pruning. And here's the interesting part, right? So you somewhat turn down the focus from your eyes. You reach into the plant with your hands and using your sense of touch, you feel around for the branch that you want to start pruning. Then you dial your focus from your eyes back up and you look for the branch and you make sure you're going to cut it in the right spot and make sure you're going to cut a finger off, ideally, and then you chop, right? So if we think about what's actually happening there, our eyes are being used to survey the area, and our hands, they're not just doing the task, right? Our hands are providing some sort of real-time feedback as to where they are and what they're doing. Right. Got to click. So our hands, right? They're feeling around inside the physical world, right? And that is exactly why you need a 3D model that represents the physical world. The 3D model ends up becoming the source of truth that then we can start to build the robotic arms and tools off, that then when paired with robotic skins, which the University of Canterbury is also working on, you can actually start to interact with the real world. How do robots that can prune and harvest and thin trees, how do they affect the spraying of harmful chemicals? So this is kind of my prediction as to how these are going to play out in the market, right? And I think of most farmers when they buy a tool that can do one thing, or they buy a tool for one thing but it can do 10 things, it ends up doing 10 things, right? I think back to using my fencing pliers as a hammer. They came quite handy. So if we dive into the numbers, roughly 70% of a grower's costs are their current labour costs. So these are your pruning, your harvesting, your thinning. So first things first, these robots are going to be built up to target those massive financial costs. But once that's been done, that's when the real magic starts to happen. If you've got a robot with a robotic hand that can see and do things, essentially, that you're going to deploy it to do the things that you're currently using your sprays for, right? So we use our sprays right now because the way that we used to do it, which was manually, is far too expensive to run a business off. But every single grower that we have spoken to has said that they would jump at the opportunity if they had robots that could go out there, work 24/7, 365 days a year, tending to each and every tree, picking out each and every weed, manually removing bugs. They would jump at the opportunity to do that. They would all love to be able to leave the land in a sort of better way than they found it, not destroying it with chemicals. And they'd love to be able to focus on doing what they love doing most, which is growing the best possible food for you and I. So, yeah, so from Matilda and myself and the UC Vision team, thanks for listening to us. And I just want to say thanks as well from Matthew Matar, who is the man behind the robot, who's going to come out and answer some technical questions.